You know, whether it's your car or your kitchen blender, there's a hidden world humming away inside. A world of spinning teeth, turning power into motion. We're talking about gears. And the difference between a machine that's whisper quiet and one that's just screaming, well, that comes down to an incredible science of microscopic perfection. Okay, so here's a question for you. Why is it that a brand new electric car can just glide down the street in almost total silence, but an old kitchen blender sounds like it's tearing itself apart? I mean, they both use gears, right? So what's the deal? Well, the answer is the difference between just any old gear and a perfected one. And that's a story that's all about mind-boggling precision and a really deep understanding of physics. All right, so to really get how engineers pull off that silence, we've got to start with the noise. It turns out no gear is ever truly perfect. And even the tiniest, most microscopic flaws, they can have some very, very loud consequences. See, what research shows is that even the smallest manufacturing errors or design quirks create this big domino effect. We're the ones who hear the vibration and the noise, right? But what's happening behind the scenes is that the load isn't being shared evenly. Parts are getting stressed out, which causes them to wear down and fail way, way sooner than they should. Now, one of the main villains here is this really fascinating concept called time-varying mesh stiffness. Think of it like this. Imagine you're walking across a rickety old bridge. For just a split second, two pairs of gear teeth are connected, and that bridge is super stiff. But an instant later, only one pair is touching and it's suddenly way more flexible. This constant change in stiffness, happening thousands of times a minute, is a huge source of vibration. And then there's this other thing called backlash. It's this tiny microscopic gap that has to be there between the gear teeth, otherwise they just jam up. It's totally necessary, but man, it is a double-edged sword. If there's too little backlash, the gears will literally grind themselves to pieces. But if there's too much, you get that clunky, sloppy feeling and a whole lot of noise. It is such a delicate balancing act. So, how on earth do you fight back against these invisible forces? Well, the first solution is surprisingly direct. You physically reshape the gear tooth itself, on a scale that's almost impossible to see. The whole process is called tooth modification. And honestly, you can think of it like, well, like high-tech orthodontics for machine parts. By shaving off these unimaginably tiny bits of metal in exactly the right places, engineers can totally transform how the gears act when they're under pressure. So let's break down the main tricks of the trade. You've got tipper root relief, which is all about smoothing out that very first moment of contact between the teeth. It kind of softens that jarring step onto the rickety bridge we talked about. Then there's lead crowning. This subtly curves the tooth so that the load always stays right in the center, even if things get a little misaligned. And for the really tough jobs, engineers will combine a bunch of these methods into what's called a compound modification. But here's the thing, reshaping the gear after it's made, that's only half the battle. The real revolution is happening way before that, before any metal even gets cut, in the world of computer design. See, the old way of doing things was always a compromise, right? You'd make a gear stronger, but whoops, now it wears out faster. It was a constant trade-off. But new research is showing how these incredibly powerful algorithms can now do something called multi-objective optimization. So instead of a human engineer making compromises, a computer can run thousands of virtual tests to find the single best design that perfectly balances everything: strength, durability, and efficiency, all at the same time. And what's so cool is that this process spits out these unbelievably specific answers. For one particular gear, the algorithm figured out that a pressure angle of exactly 24 degrees, that was the magic number. That's not some engineer's best guess. That is pure math, finding the perfect form. All right, let's kick it up a notch. Because, let's be honest, a perfect gear sitting all by itself is, well, it's useless. What really matters is how it acts as part of an entire system. This incredibly complex dance of moving parts. So the big takeaway here is that engineers today, they're not just looking at one gear. They're creating dynamic models of the entire transmission, factoring in everything from the shafts and the bearings to the oil that's lubricating the whole thing. They're not just designing a part, they are choreographing a performance. And this is where things get really wild. Research shows how all these different factors play off each other. So yeah, you can cut down on vibration by making the teeth a little less stiff, or by increasing the damping, which is basically just adding resistance. But the really mind-blowing part is what they found out about backlash. Get this. That tiny little gap we talked about, the one that causes so many issues, well, it turns out that if you get it exactly right, it can actually stop resonance. That little bit of slop in the system can act like a circuit breaker, preventing catastrophic vibrations from ever building up. It's just a beautiful example of finding order inside of chaos. So you've got to be wondering, right? How in the world do they find that perfect resonance-canceling sweet spot in something as complicated as a car transmission? Well, that brings us to the ultimate proving ground for all of this modern gear science. Yup, the electric vehicle. In an EV, there is absolutely nowhere for imperfect engineering to hide. Think about it. In a normal gas-powered car, the rumble of the engine covers up a ton of little noises and vibrations. But in an EV, it's dead silent. Any tiny little imperfection in the transmission is felt instantly by the driver as a shift shock, that little jolt that completely ruins the feeling of smooth, seamless power. So here's how they solve it. Research shows an EV gear shift is like this perfectly choreographed 4-step digital ballet. The electric motor dials back its torque for a microsecond. The first clutch lets go, the second clutch engages perfectly, and then the torque comes right back on. All of it happening in a fraction of a second, all controlled by software to be totally unnoticeable. So you can see, right? A smooth shift has always been important in automatic cars, but the stakes are just so much higher in an EV. It goes from being important to being absolutely crucial, because that one moment of imperfection isn't hidden by engine noise anymore. It basically defines the entire driving experience.
Okay, so let's zoom out and put all these pieces together. That silence you hear in an electric car, or the smooth hum of a really high-end power tool, that's not an accident. It's the result of decades of research into these incredibly complex, totally invisible systems.
What we're seeing is that true gear perfection is kind of a 3-part recipe. First, you have to sculpt the physical tooth with microscopic precision. Then, you use these powerful algorithms to create a smarter blueprint from the very beginning. And finally, you have to master the chaotic dance of the entire system and choreograph the whole thing to perfection. So the next time you're in a car or using a tool and everything just feels effortless, you'll know why. You'll know about all the invisible science working under the hood. The only question left is, what are you going to be listening for now? That subtle perfection? Or maybe the tiny little flaws that tell their own story?